Welcome back. This is the next video about the very basics, the basic principles of using Grasshopper and introducing the Grasshopper user interface. In this video, I want to introduce the Grasshopper object types and the wiring logic. Primarily, there are two types of user objects. We have parameters and components. Parameters store data, numbers, colors, geometry, and more. And you can see a list of the parameters here under the category of parameter palette. Parameters might be geometrical matters, can be points, circles, curves, surfaces, whatever. And they can reference geometry from Rhino or inherit geometry from another component here in your Grasshopper canvas. There are also some primitive parameters, like, for example, texts, numbers, integer numbers or floating numbers, any sort of data. It can be a domain or matrices. Also, parameters might be a sort of information you give to create a form, and we call them input parameters that are kind of dynamic interface objects that allow you to interact with your definition. The very well-known and mostly used parameter is the number slider here. You can see you can go to the input palette and drag and drop the number slider, or another way to call for a number slider onto the canvas is to double click on the canvas and give the minimum and maximum of the number slider that you want. For example, I would say 0 and 10, 0 less than 10. So I define the threshold of the number slider. It's good to also talk about the number sliders a little bit more here. You can double click on the number slider and define what kind of number slider you want to have on canvas. You can pick, for example, floating numbers or real numbers. You can pick natural numbers or even or odd numbers. And based on that, you can pick how many digits you want to have. In architectural design, it's usually common to have like 1 or 2 decimal places when you're using real numbers. But for example, 3 or 4, rarely you get to use that. So I usually recommend students not to use like 3 digits of numbers, which is the default of Grasshopper number sliders. We usually go with integers like natural numbers or real numbers. And even when you want to pick integers, you can just click on floating point number and reduce the number of digits to 0. So then you can have negative and positive values. And here you can see the minimum and maximum is set here. You can at any time change it by double clicking on the minimum and maximum, give it a number. For example, I say 1, and then click on the check button to change the minimum value. And then when you press OK, then that's meaningful. You can, similar to other input parameters, you can give the number slider a name, and I highly recommend that to do it. For example, you can say that this is the amount of radius of a circle. Please be thoughtful of setting the minimum and maximum intervals of the sliders. For example, a circle with a 0 length doesn't really make sense. And it usually, if you set it to 0, then it will lead you to come up with like some false or invalid results. So really think about what is the minimum, what is the actual minimum value of the radius you want to have when you are exploring the different alternatives of the design solution. So if one is meaningful for your project, you can pick one. It might be like 5 or anything. You want, for example, you say, I want to draw like a dome. I want to create a dome with a minimal radius of 5 feet. So you can just like set it to 5. So this is about the number slider, which is the very common input parameter. There are also other input parameters, like, for example, panel. Panel, again, is very common, is a very commonly used parameter. You can just, again, drag and drop the panel onto the canvas, or you can double click on the canvas and type // and then hit enter. Again, like sliders, you can name the panel. For example, you can say the list of center points, and like clarify what the kind of information you're going to use. Panels can be used at any different situation. You can just like add notes like as post-it for yourself when you want to like get back to your script a few months later and you want to remember what was specific about that kind of script that you created. You can use the panel and just drop it somewhere and have the information that you want. Also, you can like make a list of numbers or include just one single number. For example, when you want to draw a circle, and you want to give it a radius, you can either like use a slider, number slider here. Let me just turn this off. You can just use a number slider to define the radius, or you can simply, for example, this one, you can just give it a number like 8. But remember that then always this circle will have a radius of 8, so that number is fixed. For panels, you can also right click on that and change panels from a list of like single input entry to like multi-line data. In this case, you can click on that, click on the panel and give a list of numbers. For example, imagine that you want to create multiple circles and you want one of them have like a radius of 4, the other one 8, the other one 10, the other one 12. Remember, in this situation, if you hit enter and do not enter anything, then you will come up with an error, because Grasshopper considers enter or space as a character. And then since there is not a number, then you will come up with trouble. So you should delete that part. So now I have a list of 4 input values, and then I'll give that to the circle. Now I have 4 circles. Something that is important to just mention very early at the beginning is that your list will be indexed from 0 to whatever number of input values you're using. And the list index will begin with 0. So if you have 4 numbers, the index number will be 0, 1, 2, the index numbers will be 0, 1, 2, 3. It doesn't start from 1. Just be careful of that. The other input, the other commonly used input parameter is the Boolean toggle, which has like 2 situations of true and false. We'll use this toggle when we want to, for example, run a simulation or define an if condition. So when we get to that, you'll get to know that more. There is another input parameter that you might want to try is the button. Button is also letting you to run a simulation. So this is another input parameter. Let me just a little bit of cleaning. The other input parameter is the multi-slider. The multi-slider lets you pick two numbers at the same time. And similar to sliders, you can set a domain and say, for example, 1 to 5. This one I want it to be 0 to 5, and the other one I want to be 0 to 10. Okay, so this number will be the maximum 5. This will be 10. And then at any point, you will be given two numbers, and you can put it there. Let me just disconnect that. Okay, so here you can see you will be given two numbers of X and Y. We'll talk about how we can separate these coordinates later, but just know that there is a very common also input parameter. The other input parameter is the value list. Again, you can pick the value list here from the input palettes. If you double click on that, you can make a list of the values that you want to input. So for example, you can say, for example, you may have a list of numbers. It might be 10, 20, 30, 40. And then you can see it. You can also give it a name. For example, I would say number of panels. So the choices will be these 4, and you can like select any of those. You can also right click on the value list and choose one of the options as a checklist, drop-down list, value sequence, or value cycles. And this one is a value list. If you select the checklist, you can select multiple. For example, you can say at the same time, I want to pick 10, 20, and 40. Or you can like say, I want to see it as like a sequence. Also, the checklist can the checklist can be a list of text. So you can, for example, say wood, concrete, steel. And that also works. So you can pick any of those. The other set of objects in Grasshopper are components. Components perform actions based on the input they receive. Like, for example, drawing a circle, or for example, doing math operations, or creating a mesh, or creating any surface. So most of these objects that you see on different panels are basically the Grasshopper components, and you can drag and drop them here. Each component usually has one side where you get where you connect the input parameters to it, and then there is another side where you can see the output values. And there is a kind of like color coding for components and parameters. I mean, basically the Grasshopper objects that let you know what is their status. So a parameter with no warning or error usually is in light green. For example, you may right click on the canvas and call for parameter point. By default, since it is not assigned to any coordinate, any coordinates of the point, it is in orange color, and there is a warning pop-up sign here that says this object contains one warning, and that says floating parameter. You can see that floating parameter point failed to collect data. So that means that this point is not assigned to anything. When you hover over this pop-up messaging sign, you can read the warning. So if you just simply right click on that component and either on Rhino or by using a, for example, a panel like this, you can give it a coordinate and connect it to this point. So now when you hover over this parameter, you can read it that the number that is, the point that is assigned to this object is 0, 0, 0. And when you connect this panel to your input parameter, or like assign a point using the Rhino interface, you see that the parameter of the object will turn into light green. So a parameter with no warning or error is in light green. That's also the case for components as well. For example, here I wanted to draw a circle, and this circle, well, basically, these circles is connecting all the like the center points that were required, and then it turns to the light green. Now let me draw a circle here. So I'm going to draw a circle. Now you can see the circle on Rhino viewport. If you click the middle button of your mouse or right click on this icon of the component, you can choose either to preview or not to preview the result. So I turned off the preview here. When you turn off the preview of a component, then the component color turns to be slightly darker gray. Also, when you right click on the component and disable it, then the component will turn to a dull gray. And you see that even the text over it turns to be dull. Now let me just enable it and set the preview on. And then when you select a component and when you're able to see the preview on the Rhino viewport, then the color of the component turned to be green. So this is the color coding for Grasshopper objects. There is one other situation when you, and that is the error, when you connect an invalid input value to a component. For example, imagine instead of the radius, I call a panel and type wood. Okay, and then connect wood here. So then the component turns green. There is a pop-up text here saying data conversion failed from text to number. So you can see what is the issue with that component. It's a very good way to debug your script here. As I mentioned, most of the components include two sets of sides, including like the input parameters and outputs. There are also some other components that they take the input parameters, but they have a jagged edge like this. Usually, when a component is supposed to display something, then there is no output because you're going to see the result of that component in the viewpoint, in the viewport. So here, under the display palette, you will see a bunch of those here. I mean, all of them basically have, they don't end up with any sort of like output list there. When you have a component, you can decide how you want to display them on the canvas. Every Grasshopper object has a unique icon and also a unique name. When you go to the view, when you go to the display menu and select the draw icon, actually I had selected that. When you select it, you can see that unique figure that showcase that component. If you turn it off, you can just see the name of that component. Also, you can, by default, this item draw full name is off, so you can just see like circle is just defined by C and R, and when you hover over the input values, you can see that there is a center point. Here is the normal, like the vector, and then this is the radius. So by hovering your mouse over these input values, you can read them. But when you click on the display and select the draw full names, you can see the full label of input and output parameters of a particular icon, which is quite helpful. But some people prefer to just go with like the first letters, just to be a little bit more concise when they're scripting and like saving more space. I believe when you display the icons, it will be helpful for you because later when you're exploring the palettes, you can more quickly find those components here. I mean, it's very normal. There are thousands of Grasshopper components available to you, and it's sometimes hard to find the component that you want. So if you get used to the icon, you can easily find those in the palettes. Another good way for finding components is to just doing double click on the canvas and just write down what you're looking for. For example, I maybe say circle, and then there are a number of different components that let you draw circle. You can again hover over those titles. Circle, which says create a circle defined by base, plane, and radius. You may look for a situation when you can define a circle by center, normal, and radius, or by tangents of two curves or other situations. So based on what kind of situation you want, you can drag and drop the component that you're looking for. As you explore further the different Grasshopper objects, you may even not know what kind of input data you should provide for a component to run. So you can just simply right click on the component and use the help option. Under the help button, you can read more about what kind of input parameters should be provided for that component to run successfully and what kind of output parameters you will get at the end. Also, you can hover over components on the side of the output parameters and also read what kind of data that you're getting. For example, here, when I hover over the circle output, I can read that one locally defined value, circle with a radius of 8.91 millimeter, is created. Another good way for reading the outputs is just to call a panel and connect the output to the panel, so you can read it very easily. There are one other types of objects available in Grasshopper, and those are zoomable components or like addable components. Some components like merge, when you want to merge a set of data, when you zoom over them, you can actually see a plus and minus sign here. And if you add plus, you can add the number of input parameters that can get connected to that component. Or you can also remove some of them by just clicking on the minus sign here. I think I mentioned that panels are just like post-it. It's nice that you can actually change many things about the panels. You can edit the note, you can like align it to the right, to the left, center line, and also you can change the font. So by default, the font of the panel in Grasshopper is Career New, but you can, for example, I don't know, choose Arial, and also change the size. For example, I may say I want to see it bigger. And then you see the change, the font changed here. And of course, that is not universal. So you can see that the other panels, they have a different type of font. So you can do a little bit of housekeeping, a nice thing. In Grasshopper, we have two main types of data, volatile or like, let's say, variables, and the other type is persistent types of data or permanent values. What is the difference between that? So when I'm drawing a circle, and I'm giving it a center point. We just disconnected. And then I'm giving it like a value between 0 and 10. So this will be the circle that I'm drawing. If I, as I mentioned, Grasshopper talk to Rhino viewport, and if I change the radius here, the radius of the circle will be different. But there is, so in this case, the radius is a volatile input parameter. It can be changed. It's not permanent. But if I right click on the radius input parameter and click internalize data, then this circle will have a radius of 10. I can read that when I hover my mouse over radius, and that will be it. So if I like save this file and email it to someone, then forever this will be the circle that I decided to be. But when the radius is connected to a number slider, whoever receives your file can play around with that slider and change the variable. So when you internalize the data, you turn that data to be permanent, and it will be persistent. So that is a good practice sometimes to internalize some critical values in your script if you want to make sure that that will be all set. Also, that's a helpful thing when you're capturing the output data. For example, here you collected a series of a series of center points, and you're drawing a series of circles and with the same radius, but of course with different type of with different sets of radius. I mean, all of them actually has like the same radius, or let's say even this one. So here I have like 4 different points, and I have a list of points here. So imagine that this is the output that I'm capturing. Now, if I want that kind of, I mean, data that I have here be permanent, I should call data and then connect the results to this, and then internalize that data into this component, and then I will click it to the panel and I can read it. So this data is there. No one can change it unless you do it, or like you turn it again to a kind of like volatile data and connect it to like the other input parameters and wiring them. Sometimes some of the students run a simulation, get the output, and they see the output on their machine, and when they send the files to me, there is no data because those output data are not persistent anymore. So I should run the simulation again, and I mean, take time to redo everything. So it's a good practice when you're like sharing your data, collect everything onto a data component, geometry component, I don't know, number component, and internalize data into that to be able to see what kind of, I mean, what is the exact data that you got when you ran your simulations. The last thing I want to mention about Grasshopper wiring, about Grasshopper interface, is about Grasshopper wiring. Well, there is again a kind of rule to understand how the different components and objects are connected to each other. When an object like this point is connected to a component with a thick dark gray wire with a continuous line, it seems that everything is all set. And you can just simply hover over the output of this object and drag a wire and connect it to the components that you want. If that component doesn't contain any sort of data like this is an empty point parameter, then that wire will be in red, showing that nothing is transferred. I mean, the concept of wiring in Grasshopper is similar to electrical wires that carry pulses from one object to another. So when the wire turns red, means that no pulse is being transferred. But when it is, let's say, dark gray, everything is all set. If you want to disconnect the wire, you can just hold Control, and then again drag that wire from the first object to the target object. It doesn't matter the direction whenever you hold the control button, you can like drag back, or you can drag from the first to the second, from the to the target object and disconnect it. There is another way. You can right click on the component and right click on any sort of object, and then under the disconnect, select the disconnect option. Imagine that there are multiple data connecting to the component. For example, I'm connecting this point, and I want to connect another point to this data set. By default, when you drag a wire and connect it to this object, it will be disconnected from the previous one. In order to do it, in order to connect 2, 3, or more objects to another one, you should hold the shift. So I hold the shift and then drag and connect another wire. So here I connect 3, 4 wires here. And then when I want to disconnect this wire, I can pick which wire I want to disconnect. I want to disconnect it from an input object or output object. So when you hover over the objects, for example, this point, it turned to be dark red, like a scarlet color, and then you know which one is which, and you can disconnect the one that you want. The last thing about the wiring is that you can also change the display of wires. For example, here I'm connecting many points to this merge component. If I move my mouse over the input parameter and right click on that, then I can choose what kind of wire display I would prefer. The default is this continuous thick dark gray wire, but I can pick faint and kind of make it blare. Or even I can hide the wire, and then when I hide the wire, you see that there are some sort of like wavy shape out there that indicates that this input part is connected to something. If I want to really see which parameter, I should change the display from hidden to default to see it. Sometimes some designers go with the faint or hidden wires because they just want to reduce the number of wires on the canvas and clean up their canvas, avoiding any sort of like messiness or like scattered wires, or just as a matter of beauty or convenience. But if you feel like you're okay, you can just go with the default. Okay, that was the last tip that I wanted to share with you. I think you already understood that the direction of wiring and scripts in Grasshopper environment is from left to right. So you read a script from left to right, and you can follow the stream of the code from left to right as you see. Well, we're all set with whatever we needed to know about the Grasshopper interface.